Good morning, everyone. Welcome to our Aknots team, where Daryl, Amir, Fatih, and myself, Andrei. For us, this project was a great opportunity to learn more about the technologies used in the full stack web development. And in this regard, we really appreciate the help our facilitator, Greg Fenton, provided. Without his support, it would have been hard, if not impossible at all, to implement this project. As for the app we have worked on, we all came from oil and gas industry. That's why we've decided to choose a project related to this industry, namely an in-house developed inventory control app for an oil services company. This is our story. The company has a warehouse which stores company's equipment and spare parts and ships them to the workers in the field. In the beginning, it was a small company and there was no information system. All the inventory operations were recorded and maintained in spreadsheets. As a result, several separate files were kept by different employees around the office. Many people worked on the same files, and what is important, there was no permission control at all. Every employee was able to have a look at the data files and even could copy or send the information out. The users used to make changes individually. Records had to be verified, confirmed, and merged often. So no surprise information was inaccurate and not up to date. There was a huge space for mistakes and discrepancies. So as a result, frequent physical counts were required, which is a time-consuming and costly process. So this kind of old-fashioned style was rather tolerable when the company was small. But with the company growth and expansion, the scales of problems increased as well. So a technology-based solution became critical. And now more details on the implemented solution will be provided by my teammate, Amir. Amir?
Thank you, Andrei. As mentioned by Andrei, to solve the problems faced by having a spreadsheet-based inventory, we wanted an app which is secure, easily accessible, reduces data and inventory errors and duplications at the same time. So we developed an app with a database stored on the cloud, which gives us an advantage of having a system which can be accessed from multiple locations, like a person sitting on the reception front desk using a laptop, or physically behind in the warehouse carrying a tablet. The users which are authorized and verified through the database with proper credentials, which they have the option of filtering and searching the data to receive and issue the orders. They also have the option of checking which brand of items they want to order and which preferred supplier they want to order it from. Obviously, keeping in check the quantities available to properly manage the stocks, and all of this is done in real time. The data is also validated to prevent any irrelevant or junk data being entered in the system. And this we have done by creating proper schemas which check all of this when the data is being entered. And to summarize, that results in better efficiency, satisfied customers, and increased revenue at the end. And when we developed this app, we developed it in keeping in line, the learning objectives of this course as a full stack developer. And in the coming slides, my colleague Fatih will give you an overview of all the technologies we used to overcome these challenges. And on to you, Fatih.
Thank you, Amir. Hello, everybody. We built our app using the Mirror technology, which stands for MongoDB, Express, React, and Node, which are the four key technologies that make up the stack. We used Node, which allowed us to write a JavaScript code that runs directly in a computer process instead of in a browser. We used Material UI, which starts off with a large library of components and have access to fully customized theme, which is a nice thing about using a fully connected component library. Also, it is a very well-known and excellent table format and layout. We used React as our open source JavaScript library that we use it for building our interface. React also allows us to create a reusable user interface components. We use Express and MongoDB, and we use Express as our framework for building our application on top of Node.js. It simplifies the server creation process that is already available in Node. We use MongoDB, which represents the data as a collection of documents rather than tables related by foreign keys. This makes it possible for the various types of data dealt with over the internet to be stored decently and accessed in web application using Node. We used Mongo's as our object data modeling library that provides a rigorous modeling environment for the data, enforcing structure as needed while still maintaining the flexibility that makes MongoDB powerful. We use the Passport.js because it's a flexible authentication middleware that can be fully customized and works great with Connect and Express. We deployed our app in Heroku as our platform because it's elegant, flexible, and easy to use, offering us the simplest path to getting our app to the market. Heroku is fully managed, giving developers the freedom to focus on their core product without the distraction of maintaining servers, hardware, or infrastructure. We used Postman for testing endpoints. We also used Formic for enhancing the user display for the screens, and we use Yup for validating user input. Thank you very much, and I will hand over the mic to Daryl for the demo.
Good morning, everyone. Welcome to the Aknots Inventory Control demo. And today I'll be going through all the features that we have in this inventory system. The system is currently restricted to employees that have the correct credentials to gain access, and through that we use Passport and Bcrypt. And the first and most basic of all these is the inventory tab here. And here we get a snapshot of what we have in the warehouse. So it's identified by, in the bottom corner here, showing 15 records, and the user can scroll through each one of these records that they like. As well, we decided that 6 fields were required to adequately describe our records. So ranging such things as product ID, supplier, quantity. We figured this would validate quite easily and recognizable what a correct record would be. Of course, this would not be very well to use for a large database. So of course, the next logical step was to create a search database or search feature. So the same 6 fields are here across the horizon here, but we decided that 3 of these here should be automatically pulled down, so pull the information that is currently for each one of these fields in the database from Mongo. So here we can see we have 4 registered here, for instance, we have 5. And the reason why we kept things like the item name free for the user type in is that if it was a large database, you could have hundreds of items here and it wouldn't be a very effective pull down menu and wouldn't be a very good user experience. The internal ID is a little bit special, even though it's open. It does have a lot of significance, as I'll show during this whole presentation. So for instance, if we wanted to find a drill bit that we have in inventory and you couldn't remember right off the bat, we get a record return here of about 7 items. And here we can see scrolling through, we have 7 items. If we want to further filter it even further, we could select a brand such as Smith, made by Schlumberger. And here we get about 6 records. Now, if it's something like the user used all the time, they wouldn't have to go through all that. If they remember that it was a daily item, that's always item 1, for instance, they could just quickly go into here, type it in, and retrieve the record if they want to. And here I'll just go to where the page it's on. Sorry about that. Now, the next feature is the ability to add a product. And by add a product, it means that something that has not already existed. So there is no record for this unique item. So in this case, we kept all 6 fields open, but once again, I'll demonstrate why this is a special field, the internal ID, which pretty well regulates how we record and control items going in. So in the product ID, if I want to add a new item here, and I'll just pick some default nonsense values here, such as supplier, category, let's give it to pipe, and we'll give it a quantity of 50. Now, if we did a correct entry, we should see a record come back. And here we do, we see the information across. But let's say later on the day or another warehouse worker comes along and they decide to add another product in here. So if they come along and decide, I'm going to select the internal ID of 16 again, and they put their own information, whether it's nonsense or not, and a quantity, you'll see here that nothing has been populated here to this. And we can verify that by a search. If we go back, maybe 16 in here, and we can see that the original information was not compromised by the second entry. Just our way of protecting our data. The next feature, and the most important feature, is be able to regulate and record items coming in and out. So we have 2 choices: receiving for when we receive goods to the warehouse and the warehouse worker wants to enter them. We also have the ability to issue items. We added a few more bells and whistles here. As you can see, the buttons are deactivated here because we have not made proper validations in here. So we use the yup validation scheme here to ensure that we have the correct information. So if I try entering an alpha character for a numeric field, of course, we're going to get an error, and immediately you get some user feedback saying you have not selected the proper information. It's asking for a numeric value. So if we put our 16, for instance, the last record we just did, we confirm our product, and depending on whether the person is receiving goods or issuing out to the worker, in this case, let's say we're receiving some stuff to the warehouse, we enter 5. Our button now becomes active because it's a valid entry. We update our product, and now we have 55. If we, for instance, were issuing and we decide to issue 60 items, we're going to see that there's an error. And obviously an error because we cannot issue what's more in the warehouse would signify that there's some error, something happened along the way and should be investigated. The next thing would be to confirm that. We can go here, check our value, make sure that hasn't been overwritten. And we see here now that we have a quantity of 55. So the record has been intact. Finally, looking at the last.
Daryl, just a heads up, 2 minutes, okay?
Yep. Finally, on the delete page here, we have the most destructive of all. If we find some item is obsolete, we'll go in, or it's been an error, we'll enter it in. We'll confirm the product. It's now been identified, and we can delete the item. We now go back and check our search, enter it in here, confirm that the record no longer exists, and we can scroll through that we only have 15 items. And finally, for security reasons, we have our logout button. We simply go here, log out. It tells us we are officially logged out and would require anybody to enter would have to use their credentials. Thank you for watching our demo. And once again, a shout out to our facilitator, Greg, as well as some team members and also some other classmates that gave a lot of moral support and guidance on this project. And I'd like to hand this over to our host, and thank you for watching.